Okay, good evening, Norlin, Nora, and Diane. Today we are continuing our materials about the data analytics in terms of the financial technology and data analytics of specific courses. And for this night or in this sessions, we learn to talk about the optimalizations or optimizations. This is extended the extended materials after the relationships that we talk about the regressions analysis that you need to predict some variables or predict some symptoms that you have the predictors and you need to confirm that your prediction analysis is must be precise or comfort with the informations that you need to and you want to uh, make some decisions. So starting about the optimizations, we need to know about what is the optimizations. When you learn on when you hear about the term of optimizations, what do you think, Norlin? What do you think about the optimizations? Mhm. Sorry.
Again, sir, I can clearly hear your I'm having audio problems due to my environment.
Okay, no problems. I want to maybe Diane is clear for you that what is your suggestions or your opinion? What is the term of optimization?
It's like turning an event into its like most favorable outcome, sir.
Mm-hmm.
They like
Yes.
optimizing the result like
Yeah.
that.
Okay. I think that's similar like that. You have some alternatives. You have some options that you need to make some decisions that where is the optimal. The keyword is the optimal or the potential solutions. And in this data analytics, we learn about the quantitative data. When we don't talk about the qualitative, we are analyzing the numbers or the quantitative data. So when we learn about the descriptive, the inference, and also with the relationship with the regressions, we have some powerful tools in statistical analysis, and also we have the flexible methods. The any kind of methods, we call it about the optimizations, sorry, the optimizations. And today we will learning about the kind of optimizations in changes or in the suggestion to create some good decisions about the optimal of your choice. We need to know about that your variables have the products mix or they are combining not only with one variables. It could be combined with another variable or another potentials. So we have some a possible approach to calculate about the potentials decision making. We're starting about the algebra or the mathematical functions. And also we have the products like the Microsoft Excels, or we have statistical tools like the solver, or in the simple way we have a graphical analysis. So that's all the possible approaches that we need to learn about how to create optimal solutions. So we can start with the first alternative. First approach is about the algebra model or with the mathematical models. If you learn about in the mathematicals, we learn about the definitions or denotes about the x, the y, or maybe with the number with the square or maybe with the square roots, and then we need to calculate what is the number behind our denotes, behind the x, behind the y, or with the another of numbers that we need to predict. Sometimes we also using the another approaches using the graphical solutions, but the basic point, you need to draw about the potential solutions. You can find the solutions like these ones. Maybe you need to confirm about where is the constant point in here. And you need to draw about the optimal solution. And this one with the declining about the graphical is talk about the ISO profit lines, that this is the diminishing of our profit in this context. So this is how we draw about the optimal solution that we need to offer to our decision making. If you have more than one solutions, maybe in two or three or more than that, more than solutions, we call it about the sensitivity analysis, because you have more sensible solutions, more than one solutions, not only with the single solutions. We call it the sensitivity analysis. And it could be described in two positions. The first one is we report in the sensitivity reports, and the other one we have to report in the solver table. What is the sensitivity reports? It's like your reports that you have the options. In this case, we have two options. If you have the basic point in here, and then for the final value, and this one is the producing. And also with the another options about the labor. This is for labor use, for assemble, and this one for labor use for testing. We have the options, not only the single option, but we have two options, or sometimes we call it the plan A and plan B. That is the sensitivity reports. In difference of about providing about the analysis, we also describe the information in solver tables. In solver tables, you need to give some potential solutions with the fixed range. For examples, we have the 500s range. This one is moving about the 500s, and it's still continuing under until the uh, potentials potentials problems or the potential solution that we need to uh, conduct in this our case or in the solver table. That's the difference between the sensitivity report and the solver table. And how to compare about these descriptions. They also have the similar and the advantages and the disadvantages. And you have to focus on your sensitivity report. You only focus with the one coefficients. But in the solver tables, you have a various of the potential solution. So when sensitive report, we talk only with the one coefficients or one observations. In the solver, we have more than one solutions or more than one coefficients. All of the report and the solver tables, they are having the useful of informations. But in this additional of the solver tables, you have some experimentations. You need a difference range, maybe in 800s, 850, 900s, and more than that. So you have the more provide some useful informations. And for the outputs, they have the difference. That's the solver table have various of output because they have more than any inputs. That's why we compare about the sensitivity report and the solver tables. And in our case, in the quantitative analysis, we need to start on the linear model. Sometimes we also found about the non-linear models, but for the analysis in statistics, we have a linear model because the linear model is more easiest to predict or to forecast. They have the same magnitude and well scaled when our model in a linear positions or in any linear graphical. What thing about your models is unlinear or non-linear? Sometimes we have the quadratic model like this one, quadratic model, or maybe non-linear model like this one, climbing hills. That's not in linear models. So if you found about this one and this one, we call it about the invisible model, or sometimes we call the unbounded model, because they are not linear. And linear is talking about the visibles that we can predict with the mathematical or the statistical analysis, and we satisfy with all of the constraints. They have some constraints, but it's given to us with your data, and it's possible to be have some solutions. But if your solution is more than linear models, you have some invisibility model, or sometimes we call the unbounded model, because we have the uh, difference level. We call it the upper level and lower level. Don't forget about your analysis if you have the several time of periods. Your period of observation is not in one time. It's called about the multi-period of models, because you have more than one time, maybe in a 10 years, 15 years, 12 years. So if you have some multi-period models, your focus of your predictions is only for the short run, not in the long run positions. You only predict in the short term because they have periodical of analysis, or they have the periodical problems like the autocorrelations, or maybe the cross sections period problems. So when we comparing about the combination of the statistic using the mathematical models or algebra, and we compare to the spreadsheet models, I think it's very similar. But the first one is without the tools, the statistical tools, and the another one for the spreadsheet model, we are using the statistical tools in our systems. When we using about the statistical tools, it's called about the decision support system, or DSS. At the DSS, you can using about the solver tools, or sometimes you can use with the Microsoft Excels or SPSS, or with another statistical tools like eViews or Stata. Which one do you prefer? They are called about the decision support system. Yeah. That's for the introduction about how we make, or how we need to create optimal models. You need to offer more than one solutions. In other terms, you need to have some alternative solutions. When we talk about the regressions in the last meetings, we have only one potential solutions, but you need to think about another factors or another variables that you can predict with your forecasting analysis. So we need to provide more than one of solutions. We call alternative solutions, or in this case, we name it the optimizations model. Okay. Before I continue, any question from Norlin or Diane?
None so far, sir.
None so far. Thank you, Diane. How about Norlin?
None, sir.
Thank you. Thank you
None,
for your
sir.
response. Okay. Let's continue about the optimizations model. In optimization models, the keywords is you need to have alternative. You have alternative solutions. Why you need alternative solutions? Because in a reality, your variables, your observation is changed over time. In economics, we call the dynamic analysis, because sometimes we can predict clearly or with imprecise. Sometimes it can be precise. So the situations is changes over times. So that's our reality about the data analytics. So we need this optimization model to create or to have the best solutions. In kinds of find about the best solutions, you need to blend your analysis. The blend analysis is talk about the mix of your inputs, and also you have the mix of your output. You can fill with the one variables or more than one variables, and then you can conclude about more than one or two alternative solutions. So they called about the blend analysis. In the another models, we also find about the logistic model. The logistic model is like the companies of shipping destinations. We have the we need to find about the minimum cost of shipping, or sometimes we have the free of the delivery or free charge about the delivery. That's a similar like this optimization model. When you have in the this company have the capacity or the limited capacity, you need to create some alternatives, or you need to have more than one situation to determine what is the best options to create some solution for your problems. Also in the transportations models, we also have the optimizations models. Sometimes we have the any kind of mode of transportations. You can using a bus, you can using a car, train maybe, and they have a different problems. Sometimes the problem comes from the capacity. You cannot use the car when you have a group of analysis. For examples, if you want to go from another point to from your origin to your destination point, and you are going with the 6 or maybe 7 peoples, you cannot do with your car. You can use by bus or train because the capacity of your transportation is limited. Does it make sense for you? If you only go with the 2 or 3 people, you can go by your car. You can go by your bus, you can go by your trains, but you can use your car because the capacity is still in a positions. But if you have the number of your peoples more than your capacity, you need to change about your plans. You can change with your plan A using the bus, plan B using the train, and another category. And also we have the another problem for the customer demands. Sometimes the demands of our customer is having the different preference, and yeah, that is changing over time also, and also with the shipping cost of your area. Look at this example about the transportations. We are not concluding about the we are not directly through the financial technology. We are starting with the transportations. If you want to go to the another regions, you can use with this map like this one. Okay, I have some simulations in Indonesia. We have the modes of transportations or the fintech transportations using the Gojek and Grab car and the Go car. Okay, when you can comparing about the cost of your transportations from the origin to your destinations. Maybe in the you want to going to the first origins, you need to compare about the cost. Using Go car maybe in 50,000. In the Grab car, you have the 60,000. So as the rationale of the customer, you need to have the lower cost. You will choose the lower cost. That's about how we need to optimization models. Also with if you have some order for your food, you're using your applications, your fintech applications. If you are using with the first applications, you have the charts from your restaurants maybe in 5,000s. When you have another application, the charge from restaurants maybe in 3,000s. So if you are the relation, if you are the uh, rationale of your customers, you need to choose with your lowest price of your food. That's the example about the transportations and combining about your fintech solutions. Okay. In the modeling issues, we have the several effects from the customer demands. Sometimes the customers having or wants about the minimal requirement or the minimal cost. And another ones, we have the maximals of quantity. If you having a cost of the lower cost, you need to have the more of the maximal quantity. But if your price is too high, you need to have the minimal requirement. That's the customer issue in our demands. And then don't forget in our economics, you need to quantify about the discounts in price or maybe in another offer. You need to use about the discount. That is to make your predictions not linear again. And statistically, we also have the discount problem about the statistical analysis. So if you have the data analytics using the statistical model, please ignore the discount, or you need to combine, or you need to apply the discount first, and then you make some forecasting modeling using the statistical tools. Because sometimes the percentage of discount having the difference output or maybe having some error in your statistical model. In the financial models, it's also similar. We have two area in here, like the investment strategy and the pension fund strategy. For example, if you have the pension fund management, you need to over about the plan of your pensions fund. Maybe in 6 years, how much the investment that you have in the 7 year, in the 8 year, or maybe in the all up to the 15 years. Also with the capital budgeting in your investing analysis, you also have the net present value. I think it's familiar to you, or you need to find about what time of your profits or payback periods. In the first year or in the first investment, your NPV in 16,000. And the second investment, you only have the 8,000 of net present value. So you can have the combinations. And don't forget to apply about the fixed cost. In accounting or in economics, we also learning about the fixed cost and variable cost. If you have the fixed cost, you cannot do anything because it's a fix. You can do some changing with your variable cost. So I have some example in here, like the portfolio model. Portfolio model like this one. Okay, if you have three options about your stock investment, this is the stock number 1, stock number 2, and stock number 3. They have the mean of average and the standard deviations. In the first theme of our data analytics, we learn about the descriptive analysis. Okay, in the descriptive analysis, we learn about the standard deviations. If your standard deviation is high or you have the greater number, that's mean that you have a big error. So you need to choose about the minimum of standard deviations, or in the simple way, we call the minimum of error. So if you have the single investment, like stock 1, stock 2, and stock 3, if you need to choose what is the investment that is very potential for you or very optimal for you, which one do you choose? Stock number 1, stock number 2, or stock number 3?
Stock number 3.
Number 3. Good answer. Why you choose the stock number 3, Norlin?
Sir, according to its standard deviation, it has the lowest value, which is 0.08, which means that the numbers is close to the mean. So all of the observations are close to the mean value.
That's a great answer, because the standard deviation is lowest in our models. So it means that closest to the mean. Though they have the very strict of your error, the very minimum of your errors. So you cannot have a mistake of your forecast if you only have the one single solutions. Okay. How about the combinations? We need to use about the correlations. The correlations is talk about the second topic in our data analytics. Is about the inferencia. You need to correlate. If you need to choose about two investment, you need to combine stock number one and stock number two, or stock number one and stock number three, and stock number one and stock number two and stock number three. And in this part, we talk about the correlations. If you have a strong correlations, that is, they are growing together. If you have the low correlations, they are decreasing together, or they have no strong power to growing together. So in the second case about the combinations, which one combination that you need to choose?
Stock number 2 and 3.
2 and 3, that's a great answer because they have the higher correlations. It's not a strong correlations, but it's the best correlation that we have. Yeah. Thank you for your respondings. Okay, no problem, Diane. You have some internet connections. Okay, I will give you the recording so you can learn again about how to create some optimization models. So from the answer from Norlins, I have ensured that you know about how to create optimal solutions. You need to compare with your models, even in a single analysis or in the combinations. You can use about the correlations. You can use the standard deviations, which is
Yeah.
from the description, inferencia, or sometimes if you have the regression model, you need to compare about the R square. The greatest R square is very powerful to predict in your forecasting analysis. So this is the issue in our optimization model. Okay. In the next weeks we have the last meeting about our data analytics. We talk about the optimization and uncertainty. And today I
Okay.
ensure that you have to learn about the optimization model. But next week we learn about the uncertain models. Sometimes we found about the factors that we cannot predict anything, or it's given, or sometimes it's inheritance. So what is our options? So we need to learn about the uncertainty model in the next weeks. Okay. Any questions for you? From you, Norlin or Diane?
Sir, the next topic, which is the uncertainties, does it includes the risks, the different types of risks?
Yes. But we are talk about the risk in a single models or in the very simple model, because the topic is connected, optimization and uncertainty. You need to find about the alternative. Well, while you have certain conditions like this one, the optimization, and if you have uncertain conditions, that's our topic for next week. So we also talk about the risk. We also talk about the tolerance, the standard deviations, or maybe the standard errors. But I think we have to some analysis with a simple way, or in the very moderates of our data analytics. Okay, is it clear for you, Nalin?
Yes, sir. Thank you, sir.
Okay. Any questions, Diane? You can chat me if you have any questions. Okay. If you, sorry, what's this? No, sir. Okay. Thank you for responding me, Diane. Okay. I think all of our that's all of the materials for today. And the next meetings, we still talk about the optimizations model, but we need to add with some material using the uncertain conditions, not with the certain condition, it's uncertain condition. And I will send you about the file Excels for analysis to have some models with the certain condition and uncertain conditions. Oh, watching. Okay. No problems, Diane. Okay. Okay. Thank you for coming tonight for Noreen and Diane. And don't forget that we have more one meetings before we are having the final test, or maybe with the summative test too. And as I remember, I have informed you about our summative test, your score. Yeah.
Yes, sir.
Okay.
Sir, when will it be our summative test?
I will tell you the description next week. Okay.
Okay, sir.
But in this part, we are not in the presentations because you need to calculate and you have some decide what's the model that the best for you. Because we are in data analytics, not only in the fintechs. Okay. Thank you for coming tonight. Thank you for Nora for assisting us. I will stop the recording.